Hello and welcome to this video on quantitative sales forecasting. So in this video, we're going to look at using time series analysis to calculate sales forecasts, but this time we're going to look at 4-quarter moving averages or 4-period moving averages. Then we're going to look at how we use these to adjust for what we call cyclical or seasonal variations in sales. And then we'll finish off briefly by looking at some of the limitations of this approach. So previously we looked at a fairly straightforward example where we just took 3-period moving averages. This is good for kind of annual data, which we get, there's an element of naturally smoothing out. It's not too much detail, it's annual data. We smooth it out and we get a nice long average we can extrapolate and take our sales forecast from. But often in businesses, we want to look at what's happening between seasons or between quarters, what's happening throughout the year in terms of the cycle of sales. So often we look at sales data where we have for a particular year it broken down by quarter, and we then have to use a slightly different approach in order to make our sales forecast. And we use an approach here called centering. So the first thing we do is we're trying to establish an average here across a 4-quarter period. Now if we have 4 quarters here, we don't really have an average period. We don't have a period in the middle like we did with a 3-period moving average. There's no period in the middle here. That falls somewhere between the 2nd and 3rd quarter. So we have to use a slightly different approach here called centering in order to get our average. So the first thing we do is we calculate a 4-quarter total, so the total for the year. So this takes into quarter 1, 2, 3, and 4. We add up for the year and we get 580, but that falls somewhere in between 2 and 3. We then go to the next year, or using the next set of data. So we take quarters 2, 3, 4, and 1, here indicated by the red, and we add those together and we get 590. And this again falls in between the 3rd and 4th quarter. So these are called centering. These are going in between our data points. But now when we add those two together, we have a total here for 8 quarters worth of data, which we can align with quarter 3. So here is 8 quarters worth, the 580 plus the 590, which we've aligned here with quarter 3. So this is 8 quarters worth of data. So if I divide by 8, I will get my prediction or my moving average for quarter 3 2012. So here are some steps around the table showing what I've done here. So I've used this approach here of centering because I can't find straight away an average for quarter 3 because it doesn't sit neatly, it doesn't sit in the middle of a 4 period. So I do this approach called centering. I put my figures in the center here in between the quarters 2 and 3 and then in between quarters 3 and 4. I add up all the data to get 8 quarters worth of information and divide that by 8 to get my moving average. So the first moving average I've generated there is centered in quarter 3 of year 1, and it's because it's based on the data from 5 time periods, which goes from quarter 1 2012 to quarter 1 2013. Here is my moving average for quarter 4 2012. Again, the same approach here. I've got 590, which is from centered on between quarters 3 and 4 here, taking in these 4 bits of information. And then I've got 610 here based on the next 4 quarters worth of data. When I add those two together, I get a total that aligns with quarter 4 of 2012 of 1200. I divide by 8 and I get a moving average here of 150. So you might want to pause the video now and try and work out the next 4-quarter moving averages. Did you get them correct? The next 4-quarter moving averages would be 156.3 and then 163.8. And this shows how those numbers were generated. So I've now generated my 4-quarter moving average line in column 6 here. The next step is to plot that 4-quarter moving average line. So my raw data here is the blue, and then I have found a kind of moving average of the data in red. Now to generate my forecast, say I want to predict quarter 3 2016, I need to do a line of best fit, and then I need to extrapolate that line, just continue my line of best fit on, and I can start to make some forecasts about what my level of sales might be in the future. So looking at my line of best fit here, I might initially assume that my sales figure for quarter 3 2016 will be £216,000. But does that feel right? It doesn't really, because when I look at the quarter 3 data so far, the actual figures, this was quarter 3, this was quarter 3, this was quarter 3, this was quarter 3, I can see that actually quarter 3 there is some cyclical, some seasonal variations. Quarter 3 tends to be very high set of figures throughout the year. So predicting suddenly 216,000 based on my extrapolated moving average actually just doesn't feel like it's a sensible forecast. So I'm going to have to take another couple of steps here to make some adjustments for the cyclical variation, for the fact that some quarters are above the average and some quarters are below the average. So what I need to do now is calculate the average variation. So I've added an extra column here, and what you can see in column 7 here is I've looked at comparing my moving average here, 146.3, with the actual data of the time, 190. Then I compare my next quarter 3 moving average, 167.5, with the actual data of the time. So on column 7, I'm getting here the variations in average just for quarter 3. So based on all the data I've calculated, I've got 3 variations here, which compares my average to what actually happened in quarter 3. So if I take an average of my variations here, if I take an average of 43.7, 52.5 and 58.8, then I can see that my average cyclical variation for quarter 3s is 51.67. That means my forecast needs to be 51.67 higher in quarter 3 than my moving average line suggests. So rather than 216,000, I need to add on 51.67 thousand to get my actual predicted sales forecast for quarter 3 2016, which is £267,670. You might like to now try and repeat this process for quarter 1. Again, remember we have to calculate the cyclical variations by calculating the variation, actual minus the trend. Then we have to calculate the average cyclical variation like we did for the quarter 3s. So you might want to pause the video and see if you can do it here for quarter 1. Did you get an average cyclical variation here of minus 33.4? We can see that in Q1 our moving average tends to be above the actual figures. So it was above by 42.5 in the first quarter of 2014. It was above by 31.3 in the first quarter of 2015. So on average, we need to make sure that our forecast is lowered by 33.4 to give us something that bears resemblance to the actual figures. So we'd then continue that process for quarter 2 and quarter 4, and then we can make forecasts using our line of best fit and adjusting for the cyclical variation of what we think our sales forecast would be by quarter. So in this series, in this video, we've looked at calculating a 4-quarter moving average through the process of centering, and then we've looked at adjusting our forecast to reflect cyclical or seasonal variations by quarter. The final point here we're going to look at is just to look at some of the limitations of this approach. So some of the limitations of quantitative sales forecasting: the past is not always a good indication of the future, so what has happened historically might not be a good basis for a forecast. We need to also consider what's going on in the external environment, and if there are significant things going on in the external environment that we are struggling to predict, this might make our forecast less accurate. We also need to maybe question the quality of the data. Are we sure about the data that we're using? And lastly, remember, the further into the future that we predict our sales, the greater the uncertainty will be. So to wrap up in this video, we've looked at calculating 4-quarter moving averages, adjusting them to reflect cyclical variations, and some of the drawbacks of time series analysis. That's it. Thank you very much for listening.